Okay, so using exponent rules to evaluate expressions. The first thing that we need to work on is that we need to understand the various different exponent rules. And there's about 7 of them, if you really think about it. The first one is very obvious. So the first one is if you've got any number to the power of another number, what it is that's equal to that base number multiplied by itself n times, so this many times. So it's so that's n times multiplied by itself n times. Okay, so that's kind of the first rule, if you want to call it that, and that's a very basic rule that we kind of should always understand. Now, the next rule I'd like to talk about is the multiplication rule. So if you have, I'm going to use a different letter here. I'm going to use, say, the same basis first of all. So if we've got, say, x to the a, right, and that's multiplied times x to the b, right, that's equal to x to the a plus b. So you just add up the exponents, right? An example of that is, let's say you have 3 to the power of 2, and that's multiplied by 3 to the power of 4. If you really think about that, this is basically 3 times 3. That's the first one. All right, let me do this in blue so you can see it. Times 3 times 3 times 3 times 3. And as you can see, that's 1, 2, 3, 4, 5, 6. So that's 4 plus 2. It's equal to 3 to the 7. All right, so that's the multiplication rule. The next rule, right, is the division rule, and it works exactly the same way as the multiplication rule. If you've got, say, y to the n over y to the m, that's basically the same as saying y to the n divided by y to the m, any way you want to do that. That's equal to y to the n minus m. And if you really think about that the same kind of way, if you've got a, say, 4 to the third power divided by 4 to the second power, that's equal to 4 times 4 times 4 divided by 4 times 4. And if you remember your rules about division and multiplication, you can always multiply this times 1 just so that you have the identity there. And these cancel out. That 4 cancels out with that 4. This 4 cancels out with this 4. And you're left just with 4 over 1. So that's equal to 4. And that's basically 4 to the power of 1. And that's the same as saying 4 to the 3 minus 2, which is equal to 4 to the 1. Right? So we have our basic property, which we about exponents, which we've known for a long time. We have now we've got our multiplication rule, and we have our division rule. Okay. Okay, so moving on. The next rule I'd like to talk about is the exponent of an exponent rule, and that's actually the rule that we've got in play right here. Okay, this tells us that if we have the base to an exponent, and that is to another exponent, that's equal to the base to the exponent times the second exponent. Right? And if you think about this as an example as well, if we take 3 to the power of 2, and we say, I'm going to make that 2 blue, and we say that's to the power of say 5. Okay, this is the same as saying 3 to the power of 2 times 3 to the power of 2 3 to the power of 2 times 3 to the power of 2 times 3 to the power of 2 times 3 to the power of 2. Okay? So as you can see here, we can break that out even further, and that becomes 3 times 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 3, and if we count those up, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is the same as 5 times 2. So that's equal to 3 to the 2 times 5, which is equal to 3 to the 10. Okay, so that's the exponent rule. Another important rule that we should bear in mind always, right, is the anything to the power of 0. And that is important to know, that anything to the power of 0 is equal to 1. One of the really interesting things this brings about is when we have positive exponents. So if we've got, say, 2 to the power of 2, that's 4. And we've got 2 to the power of 1, that's 2. And we've got 2 to the power of 0, that's 1. Now when we go to 2 to the power of negative 1, what's that? And that's what makes things really, really interesting, because that brings up the next rule, which says that anything to the power of negative something is equal to that thing as the denominator. So 1 over that thing to the power of the positive exponent. This is really interesting because it means we just use the reciprocal. We flip it over and make it 1 over something. And an interesting kind of side effect of that is if you have an example of, if you got, say, 3/4 to the power of negative 2, well, that's then going to be equal to 4 over 3 to the positive 2, which is going to be 4/3 times 4/3, which is equal to 16 over 9. Okay, so it just flips it over. Right, that's what the negative actually does. So interestingly, what you actually notice now, when we go back to this table that we're creating right here, okay, we have 2 to the power of negative 1 becomes 1/2, and 2 to the power of negative 2 becomes 1/4, and so on either side. Okay, so that's the 0 power rule, followed by the negative exponent rule. Okay, that's pretty much it for now. There is one final one, which is the fractional exponents one, which I want to deal with separately. Okay, I hope you took notes during that. So we'd like to talk about this particular problem right here. We've got 4 to the power of 10 to the power of 12. It's all to the power of 12, that is. And if we look at this, we can use the exponent of an exponent rule. So the power rule, we can use a power rule which tells us that any number to the power of another number all to the power of a third number, doesn't matter if any of them are the same, is equal to that base number to the power of each of the exponents multiplied by each other. Okay, so we're going to use that. We have 4 to the power of 10, all to the power of 12. That's going to be equal to 4 to the power of 10 times 12, which is equal to 4 to the power of 120. And that's the form that it's actually asking for. It's not actually asking us to solve this at all. So if we were to actually go and try to solve each one separately, we would be at this for a very long time, and we don't need to do that. So our answer here is 4 to the power of 120. As you can see, this doesn't always work. That took a while. Interestingly, one thing for you to remember is when you're on Khan Academy and you're trying to fill this in, as you can see I had some trouble with the pen here, when you're trying to fill that in, what you need to type in is 4, and right above the 6 you got this hat or circumflex or chevron, whatever you like to call it, this symbol right here, followed by 120, and that will give you an exponent in that particular way. Right. This is a very similar problem. Now, notice that we don't actually have to bring in the rule that says 4 to the negative 10 is equal to 1/4 to the 10. All right. That's actually redundant in this particular case because we're being told to give it as 4 to the power of n. So we don't even need to think that way right now. So let's just do it the same way as we did the previous one. 4 to the negative 10 all to the power of 3 is equal to 4 to the negative 10 times 3. Notice negative times a positive is a negative. So our answer there is 4 to the negative 30. Okay? Now, that, of course, it would work exactly the same way. We could eventually get that to be equal to 1 over 4 to the 30, which is our final answer, but we don't need that again because we're being told that we want 4 to be the base. So our answer is going to be 4 to the negative 30. Now, here's an interesting one. This is our division rule. And if you remember going through your division rule there a few minutes ago, we have a division rule which tells us a to the n, or I probably used like a y or something. Let's use the y that I used before. Y to the n, say, over y to the m is equal to y to the n minus m. Right? We worked that out earlier. That was our formula to work with. If you want, this matters that the bases have to be the same. It doesn't work if the bases are not the same. In this particular case, we now have 9 to the negative 12 over 9 to the negative 10. That's equal to 9 to the negative 12 minus negative 10. Be really careful here. Minus a negative is, of course, a positive. So that means we've got 9 to the negative 12 plus 10, which of course is equal to 9 to the negative 2. Be really careful with this. Different signs. We've got to use our adding and subtracting negative numbers in there. Okay, so our answer here is 9 to the negative 2, which of course is, if we wanted to go a bit further, that is equal to 1 over 9 to the power of 2, but again, not what we need. not what we need, because we're being told to give it as 9 to the n. So our answer here is 9 to the negative 2. Okay, here's where things start to get really interesting, because in this particular situation we have two different bases. Now, we don't need to worry about that too much, because we're actually being told to give the answer in the form of the two different bases. Okay, so we don't actually need to worry about that. This is actually the same rule as the power rule, except we distribute that 9 twice. Right? So if you remember, our power rule told us that a to the n all to the power of m is equal to the a to the n times m. Now, that's just happening twice. We've got an exponent. We've basically, each of these in here are just multiplied times each other. So it's like you bring this m in as many times as there are a's. So an extension of this rule would be, say, a to the, let's go a to the p, let's use n first, a to the p times b to the p, all to the power of m, is going to be equal to a to the nm times b to the pm. Okay? And that's there, of course, multiplied. Okay? Very interesting. But that what that means now is that this 9, we're just going to distribute it in to our equation. We're going to distribute it into our equation. Okay? So, using that rule, we have 5 to the power of 5 times 6 to the power of negative 8, and that's all to the power of 9. We're going to distribute the 9 in here, and we're going to distribute the 9 in here, okay, which is going to give us 5 to the power of 5 times 9 multiplied by 6 to the power of negative 8 times 9. Okay? Which is then equal to 5 times 9 is 45, so 5 to the 45 times, or let's use this times here that it's asking for us up here, times 6 to the negative 8 times 9. Remember, 8 times 9 is 72. Negative times positive is a negative, so negative 72. And this is the form we're being asked for, so we don't need to go any further. Right? So our answer here, of course, is 5 to the 45 times 6 to the negative 72. And that's exactly how you'd write it in. In fact, in Khan Academy, the correct symbol to use for the multiplication is above the 8. It is your asterisk is the symbol that you use for multiplication. Okay, back to the division rule again. 8 to the negative 11. So we use the division rule again. We're using y to the n over y to the m is equal to y to the n minus m. Remember that. Okay, so that tells us that 8 to the negative 11 over 8 to the negative 9 is equal to 8 to the negative 11 minus negative 9. Careful again. This is equal to 8 to the negative 11 plus 9, which is equal to 8 to the negative 2. All right. Again, we're being told give the base to be 8, not 1/8. So we're going to put in 8 to the negative 2. And there you have using exponent rules to evaluate expressions. I hope that you took the notes at the very beginning to have your exponent rules in place. If not, at this point you should rewind and get that in there. This is a long video, I'm afraid. This is one of the problems that will take people a lot of time, so good luck.